My name is Mohish Payala. I am studying Master of Engineering in Electrical and Electronics at Darwin University. In this presentation, I am going to explain enhancing the efficiency of organic solar cell using quantum dots. In this presentation, I am going to give you introduction about solar cell, then objective of this presentation, followed by working mechanism of bulk heterojunction organic solar cell. After that, I will explain the structure and simulation work of hybrid solar cell, its result, and at the end I will explain the fabrication process. So, first of all, as we know, the solar cell is quite popular device. It converts solar energy into electrical energy. It is a renewable energy source, environment friendly and low maintenance. So it can be a really good alternative of fossil fuels for generation of electricity. Nowadays we can see the silicon solar cells are quite popular and it having really good efficiency around 25%. But the problem with silicon solar cell is its high cost because of the complex manufacturing process and costlier raw materials. So this thing can be overcome by using organic solar cell. Basically, organic solar cells are made from polymer material and it is really low cost, easy to fabricate. In addition, organic solar cells are lightweight and flexible. But the current problem with organic solar cell is its low efficiency, and still there is a big scope of research over there. In this project, I concentrated on enhancing the efficiency. So for that, I will basically consider on these four objectives. The first one is to study working mechanism of organic solar cell. The second one is to study the enhancement of photon absorption by incorporating quantum dots. The third one is to simulate and design hybrid solar cell. And the last one is to understand the fabrication process of organic solar cell. So, working mechanism of organic solar cell. There are mainly four processes in this. The first one is photon absorption. When the sunlight absorbs in a donor material, when sunlight absorbs in a donor material, it excites electron from HOMO to LUMO. Now, because of the strong Coulombic attraction between hole and electron, this hole and electron attracted and form exciton. Now, the second process is diffusion. In this exciton diffuses at donor-acceptor interface. The third process is dissociation. In this, electron transfer from HOMO of donor to LUMO of acceptor and form charge transfer exciton. Now, because of the molecular vibrational energy, this exciton dissociated into free charge carrier. And the last process is charge transfer and collection. In this free charge carrier transfer and collected by anode and cathode. In this way, organic solar cell generate electricity from sunlight. If we enhance the efficiency of any of this process, then overall performance of organic solar cell can be enhanced. In this project, I concentrated on enhancement of absorption. So first of all, as shown in this figure, I selected the popular bulk heterojunction organic solar cell, in which two different organic material P3HT and PCBM were blended together in active layer. Here we use glass as a substrate, ITO, which is our indium tin oxide, which is our transparent anode, and this P.PSS is our Hall transport layer. And the last we use aluminum as a cathode. For enhancement of photon absorption, quantum dots were incorporated in active layer. Basically, quantum dots are nanoparticles having a size of 1 to 10 nanometer radius. Here, by considering the absorption profile of P3HT donor material, I selected quantum dots of cadmium sulfide and designed this hybrid solar cell. Now, with help of MATLAB and Microsoft Excel, I simulated by this both of result. First of all, I simulated the properties of quantum dot. As shown in this first equation, if we change the radius of quantum dot, its band gap energy can be tuned. And as shown in the second equation, the wavelength of absorbed light can be tuned by changing the band gap energy. So with help of these two equations, I derived the relation for quantum dot for a different size, and I just obtained the wavelength, like what is the wavelength of absorbed light. After that, I simulated the absorption profile of quantum dots. So for the first of all, I studied the absorption spectra of P3HT donor material, and if we just compare this absorption spectra with solar spectrum, then we can see that if somehow we manage to have more absorption, here we can see that there is a low absorption in 400 and 500 nanometer, And if we manage to have more absorption in this area, then here we can say that this we are having a really high energy, so we can overall efficiency can be enhanced. Based on the previous simulation of quantum dot, I selected 3 different sizes of quantum dot which are giving absorption peak between 400 and 500 nanometer, and I incorporated these 3 different sizes of quantum dot in an active layer. So this is this one showing the number of generated hole and electron in individual material. This blue line showing the number of generated hole and electron in P3H3 donor material, and this other 3 line, the black, purple and the brown one, showing the number of generated hole and electron in other 3 quantum dots. If we compare this both device as shown in the right figure, the dotted line showing the bulk heterojunction organic solar cell, and this solid line showing that the hybrid organic solar cell. So here we can see that in between 400 and 500 nanometer, because of the quantum dot, we are having more absorption. So if we compare all the results, we can see that open circuit voltage slightly increased and fill factor slightly decreased. But because of the more absorption, our short circuit current density increased dramatically, which pulls the enhancement of efficiency. Here we can say that the power efficiency of organic solar cell enhanced from 4.05% to 7.12%. So it can be said that quantum dot can enhance the power conversion efficiency by 75%. After that, at Charles University, we fabricated organic solar cells. As shown in this figure, there are mainly 5 layers in organic solar cells. So first of all, we just use pre-patterned glass ITO substrate. Then with help of this spin coater, first of all we spin coated this P.PSS, which was our whole transport layer, and after that we spin coated our P3H3 PCBM, which was our active layer blade. After spin coating this substrate, our substrate looks as like this figure 2. After that, with help of thermal evaporator, we deposited aluminum cathode, and after depositing aluminum cathode, the organic solar cell looks as shown in figure 3. Now, under the sunlight, we measured its performance, and this fabricated organic solar cell was giving around 0.29 open circuit voltage. And so, based on this presentation, it can be concluded that incorporation of quantum dot in organic solar cell can improve absorption of light, and more absorption light can generate more number of free hole and electron in the solar cell, and this more hole and electron give better efficiency. These are my references. Thank you for your attention.